let's get into today's lesson. So I don't want to say we're going to recap what we've done. It is sort of a recap, but we're going to just ease into this idea of patterns, working with patterns, and how we can then start to find equations, or what we call the general formula. So if we look at the table that I've given us here, we need to figure out a pattern. Now remember, the pattern is going to exist between our output values. If you think about what we have been speaking about, all of the inputs are values that we put into our number machine, for lack of a better word, or our rule, and we get an output. So we want to figure out what is the pattern between the numbers of my output. Now, sometimes it helps to write this as a list. So I have the numbers 1, -2, -5, -8, etc., etc. That's my pattern. And I now want to figure out what is happening. How am I getting from one value to the next? Before I carry on, I'm just going to remind everyone that we do not raise our hands until I say so. If you've got questions or you want to offer an answer, as Sipo's done there in the chat, all you need to do is put it into the chat. We will see it. We will answer any questions. We will deal with any issues. But the chat is where you go until I say you can raise hands. Otherwise, I don't want to see any hands. Okay, otherwise with, what are we, 133 of us, that many hands, we're not going to get anywhere. All right, so guys, if we have a look, we need to ask ourselves, how do I get from +1 to -2? Now, this is where you can think about your number line. This is where you can think about your integers, how we add and subtract. But essentially what we're doing is we are subtracting 3. Now, someone said adding -3 on the chat, absolutely fine as well. As long as you understand that there is a negative involved, that's good. And we can see that this pattern continues. If I subtract another 3 from -2, I get -5. If I subtract another 3 from -5, I get -8. And so what we see is that our pattern consists of us subtracting 3. So here in question A, where we have been asked to describe the pattern in words, we are subtracting a value of 3, or you can say adding -3, it doesn't matter. I'm just going to write both here because both are absolutely fine. All right, so both of them describe the fact that we are subtracting -3 each time. And so that allows me to then eventually start to find rules and start to use my rule to answer certain questions. So the next question here says, fill in the missing values for the input value of 10. Okay, so basically what this is saying, if we think about what these input values are here, my pen's a little bit thick here. Let's just sort that out quickly. If we think about what these input values actually represent, they are representing the first term in my sequence, then the second term, then the third term. So these input values represent a position within my sequence. And what I've been asked to do is I'm being asked to go all the way up to the 10th term. So essentially we need to keep subtracting 3 until we get to the 10th term. So we're going to do it like that. It's going to take a little bit of time, but it's fine. So the 5th term, if I subtract another 3, will be -11. The 6th, if I subtract another 3, will be -14. I haven't left myself too much space, but it's fine. The 7th term, if I subtract another 3, -17. I hope I'm subtracting 3 correctly. Yeah. The 8th will then be -20. The 9th will be -23. And like the term that we actually want, the 10th term, will be -26. So by continuing my pattern, by subtracting 3 until I get to the term I want, I'm able to find that my output value for the input value of 10 is -26. Now that's all well and good. We can do that. That was relatively easy all the way up to 10. But what would happen if I asked you for the input value of 20 or 50 or 100? We don't want to have to sit and carry on our pattern until we get to the term we want. And so this is where finding a rule or the general formula becomes quite useful to us. And so what you can see is that is exactly what I have asked you to do in question C. Grade 8s, please remember that we are only dealing with patterns at the moment. And so any other questions that you have, you need to ask before the lesson, or you need to ask at school, extra maths at school. We're dealing with number patterns right now. So question C says, determine an algebraic rule for the pattern. Okay, so firstly, this whole statement of algebraic rule, basically what I'm asking you for there is a rule that we can apply to any term. Right? And when I say any term, what I mean is I can apply it to any input number. And that's what I was saying now. You could now use this rule to find the value of the 57th term, of the 61st term, of the 88th term. Any term in this pattern, you could use this rule to find. And so this is what we talk about when we talk about or talk in terms of X and Y. And we're going to chat about this a little bit later on in our lesson. We use very specific symbols or letters in our number pattern section. But let's use the X and Y because that's what we have been doing. And we know that X and Y represent our input and our output. Okay, now, obviously what's very important is the fact that we have been subtracting 3 each time. That is, in essence, our pattern. It has to be part of our rule. And remember, I've said to you that your starting point for your algebraic rule is to use whatever you're adding or subtracting and multiply it by X. So we're going to start with minus 3 times X. All right? Now, if we go and have a look and check what that means, we need to use these inputs and we need to times them by minus 3. So if I've got 1 times negative 3, I'm getting negative 3. But that's not the output I want. I want an output of 1. So I need to ask myself, okay, if I'm sitting at negative 3 on my number line, so here I am at negative 3, and I want to get to positive 1, what do I need to add or subtract to get to positive 1? And so exactly, if we go and add positive 4, I'm going to get a positive 1. If you're not too sure why it's positive 4, let's have a look at our number line. Here I am at negative 3, 1, 2, 3, 4 takes me to that positive 1 that I want. So essentially what we're saying here is once we've times by negative 3, we need to add 4. But we want to double check that this works. So let's take our next input value. 2 times negative 3 gives us negative 6. And if I say negative 6 plus 4, I get a negative 2. That's the output that I want. Perfect. And we can keep checking for our number pattern as we go along. But once you've checked 1 or 2 and it's working, you can pretty much guarantee that's your rule. So we have found that the algebraic rule here is to take X, times it by negative 3, and then add 4. And that will always give us our output value. And so this algebraic rule that we're talking about is a rule that we can use to work with any term in my number pattern, right? So what this means is that I can now say, okay, what will the value of the 50th term be? Let's write this out. And because I know my rule, I can use my rule. So I know I want the output. I'm saying, whoopsie daisy, sorry, don't know what happened there. I'm saying the 50th term. So I'm telling us that X is equal to 50. And so I can now substitute that in. We can say negative 3 times 50, and then we can add our 4. Now, negative 3 times 50 is negative 150. And if I add 4 to that, I get negative 146. And so what I've determined here is that if I take this pattern and I extend it all the way to the 50th term, at the 50th term, I will write down negative 146. Right, and this is why it's so important to be able to find these rules, because that allows us to go further in our number pattern than what we essentially want to write down. it allows us to find certain terms in our pattern or certain positions in our pattern, and we can start using this formula quite effectively. I'm going to stop here in case anyone wants to take a screenshot. I'm also going to stop to say that if we can't focus and if you guys are going to continue to be distracting in the chat, I'm either going to start removing people or I'm just going to end this lesson, because it means that you are wasting my time, you're wasting each other's time, and you're wasting your own time at the end of the day. So we need to focus. If you have questions, you need to put them on the chat. Remember, telling me you don't understand or you don't get what's going on, I need to know specifically what you're not understanding. All right, so I need to know exactly what it is that you don't understand. If you can't see the screen, please remember that you might need to log out and log back in again to get the screen working for yourselves. That will probably solve the issue, but if it doesn't, let us know and we'll try help you. Right, so while everyone's taking a screenshot, I will take any hands of anyone who has any questions, but remember guys, specific questions. Okay, I don't understand or I don't get it. I need to know specifically what it is that you don't get. So Bukazi, I'm not too sure what you mean by the small letters. If you let me know, I can try and make them bigger, but yeah, I'm not too sure which small letters you're talking about. Watobe?
Raise your hand, please.
Ma'am, can you hear me?
Yes.
Ma'am, I don't quite understand how we get to the 50th term, ma'am. Do you mind explaining to me, ma'am?
Okay. So remember I said to you, let's go back up here and let's grab a highlighter. No. All right. So remember I said right at the start of this explanation, I said that this input, this X value represents the position. It's the first, the second, the third, the fourth. So when I say what the 50th term will be, I'm giving us a position. I'm giving us the 50th position in our sequence. And so what that means is that this 50 relates to the input value. And if that relates to the input value, what I'm telling us is a value for X. I'm telling us that X has to be 50. And so that means that in my general formula, I can substitute or I can replace X with 50, which is what I did over here. I replaced that X with the 50, the position, and I was able to determine that in the 50th position, I would get negative 146. So that's why I said if we extend our pattern all the way to the 50th term, we're going to eventually write down negative 146. Does that make a bit more sense?
Yes, ma'am, it does a lot. Thank you.
Good. Oh, sorry, guys. Okay, those of you who are confused about the algebraic rule, we did this in our last lesson, so I would definitely recommend you go and rewatch that video. I am also talking about it as we go through this lesson, so just listen to me as we go through it. But I would definitely recommend going and having a look at the last few lessons. So those of you confused with question C, again, we've done it. However, very quickly, and so again, if anyone now asks me how to explain how to get the algebraic rule, it means you haven't been listening and I won't be doing it again. The algebraic rule is when we want to write out a formula. Now, like I said to you, the important bit here is obviously that we're subtracting negative 3. That's our entire pattern. We're subtracting negative 3. So what we do to start our rule is we take what we're adding or subtracting and we times it by X. So that's why I've got negative 3 times X. Once I've done that, if we go back up here, we can see that we're not getting the output. Negative or positive 1 times negative 3 is giving me negative 3. I need an output of 1. So I need to ask myself what I need to add or subtract to get 1, and that would be 4. And from that, I've been able to establish what my algebraic rule is. And I go and double check with all of my inputs. If I look at an input of 2, so X equals 2, negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. If I go to my input of 3 times negative 3 is negative 9. Negative 9 plus 4 is negative 5. I'm getting my output. And so just by looking at my pattern, and asking myself how I'm getting from X to Y, I've been able to come up with a rule. We are going to do more, so just keep listening, but hopefully that makes a bit more sense to those of you who were maybe a little bit confused. Cabello? Cabello, there should be a pop-up to unmute yourself to ask your question. Okay. Cabello, I'm not too sure what's happening. Pop your question in the chat and we'll try to help you, or you can send myself or Yolanda a message. We'll help you there. There was a question about a negative and a negative equal a positive. That only applies when you multiply or divide. So that means when you are on the number line and you are going from -3 to +1, you are adding values, hence why we added 4. All right, so if you were to subtract, I'm not too sure if maybe this is what Mohammed you mean. If I was subtracting, let's just go to somewhere where there's space, and I had my number line. And guys, also we did this in integers, so I'd suggest going back to integers. If I'm at a negative, so let's say I'm at -1 and I want to subtract 2, then I need to move down my number line. So yes, I'm going to get to a bigger negative or a negative value with a greater number next to it. But if I'm adding, I move the other way up my number line. All right, but again, we've done this in integers and there are videos for this, so you're welcome to go and have a look there. Right, let's have a look at another example. In terms of why we have to subtract 4 here, guys, we're not actually subtracting 4, we're adding 4. So let's just make sure we've got that. We have to add 4 because in my rule, timesing by -3 is not going to get us the output, much the same as saying subtracting 3. 1 minus 3 is -2. That's not getting me the output that I want. So we're having to come up with a rule that describes our pattern. Those of you that are still confused, I'm doing another example. So listen, hopefully it's going to make sense. All right. So if we have a look at this table that we've got here, again, we've got inputs and outputs. We've got our X's and our Y's. And so we are going to see what our pattern is. So remember, if you want to, you can always write the output numbers down in order to figure out what values you're working with or what pattern you're working with. And I'm looking for a pattern for my outputs. So that's why I've written down the 5, 3, 1, and so on. Okay. If we look at this pattern and we try and establish what is happening, we can see that from 5 to 3, I subtract 2. From 3 to 1, I subtract 2. So in terms of describing the pattern in words, it's very similar to the first one in that we are subtracting 2 each time. Okay, if you want to say you're adding -2, that's also absolutely fine. Does the same thing. All right, but now remember, guys, the whole point of an algebraic rule is that you don't want to have to sit and subtract 2, subtract 2, subtract 2 until you get to where you want to be. You want a quick and easy way to find any term in this pattern, and that is why we come up with, or why we find, an algebraic rule. So yes, we're subtracting 2 each time, and that's going to be very helpful for us to find our rule, but we don't want to sit and subtract 2 until the 50th term. That's going to take too long, and it's just going to waste time. So we want to be able to find a rule here. Okay, so just let's just ignore B. Let's have a look at how we can now, exactly as this question says, find an algebraic rule. Now I'm going to write down some steps. Hopefully this is going to help us remember, and hopefully it's going to help us find our rule. So the first thing that we want to do is we want to multiply X by whatever we are adding or subtracting. And when I say whatever we're adding or subtracting, I mean in our pattern. So here we're subtracting 2. So that's the first thing I'm going to do. So I'm going to take x and I'm going to multiply it by negative 2. So negative 2 times x gives me negative 2x. Now I need to go and check, is this giving me my output? So that's the second thing I'm going to do. Whoops. Number 2, check if it gives, when I say it, I mean the 2x minus 2x gives us the outputs we want. All right, so if we now do that, I'm just going to take that away. If we now go and have a look at that, we're going to use our table. So looking at our table, we can see exactly which outputs we're working with, and we can see exactly what corresponding inputs there are. So if I take the input of 1, that's an x value. Remember, it says that right there on the table. So x equals 1. That's what I'm working with. If I say negative 2 times positive 1, I'm getting a negative 2. But the output that I want is 5. 5 and negative 2 are not the same thing. So now what I need to ask myself is, how do I get, so let's maybe put a third step here. How can I get, whoops, from the product to the output that I want? All right, so, excuse me. The output that I want, remember, is 5, as I've said. Oh, golly. So the question that I need to ask myself now is, I now need to, exactly as Alonda said there in the chat, I'm going to have to probably add a certain number. So my question is, how do I get from negative 2 to positive 5? So again, we could go back to our number line if we need to. You don't have to use a number line. Some people find it helpful. Some people don't. It's really up to you. I find number lines quite helpful, but if they don't work for you, they don't work for you. So I need to get from this negative 2 to this positive 5. Now, because I'm moving to the right on my number line, or because I'm moving in the positive direction, I'm going to add. So I need to add 1, 2, 3, 4, 5, 6, 7 to my product. So if I take negative 2 and I add 7, I'm getting the 5 that I want. Remember, that is what I wanted in my output. Right, but let's double check. So that's going to be my fourth step. Double check your rule. You can even triple check if you want, or quadruple check, whatever you want, but you need to double check it at least. So the rule that we have established is that we are going to take the negative 2 and times it by x, and then we're going to add that 7 that we've just found, so plus 7. And that should give me my output, but now I need to double check myself. So if I go back to my table, let us check with, let's get another color going here. Let us check with an input of 2. My output needs to be 3. We need to remember that. So if I go and double check, my input I said is 2. I want to check that I get an output of 3. Just making sure I've got my right values. So we take y is equal to negative 2, whoopsie daisies, maybe I should write the negative 2, times 2, and we add 7. So negative 2 times 2 is negative 4, and then we add in 7 to that. Negative 4 plus 7 is 3. Look at that, guys. My output corresponds with what I was given in my table. What this shows me is that my rule is correct. Now, again, if you want to triple check yourself, you go back up and you pick your next input value. So y is equal to minus 2 times 3 plus 7. Minus 2 times 3 is minus 6. minus 6 plus 7 is 1. Look at that. The output is correct. And because we keep getting the correct output, we know that this rule that we have just found, so this rule over here of y is equal to minus 2x plus 7 is correct. I have found the correct rule for my pattern. Okay, those of you asking how to screenshot on a laptop, it really depends on the laptop that you have. One way to do it is you can push print screen and then copy that over into like a Word document. What might be a bit easier is to just take a photo of the screen with your phone. So I'm gonna just stop here so that you guys can take a screenshot. We're not gonna have time for a full brain break, but what I do want you guys to do is just take like 20 seconds, get up, stretch, move a little bit. We're gonna carry on now in a second. While you're just taking a little mental break, if anyone has any questions, now is the time to raise your hand and ask me before we carry on. Solvo, question? Whoops. Solvo, I can't hear you. You might need to double check your audio connection. Make sure you're connected to your headphones, or you might need to unplug your headphones. Still can't hear you. Double check your audio option that you've got on Zoom. If you go, I think, to the microphone, and you can say select microphone. Otherwise, pop your question in the chat. Or like I said, if you unplug your headphones, we might be able to hear you. Okay, while you're trying to figure that out, Mohammed?
Hi, ma'am.
Hi.
So in the number where you say minus 2 times x, so we're taking the number that's in the table and we're timesing it by the number that we're saying.
When you say the number that we say, do you mean the number that we got from looking at essentially what the pattern is? So this situation up here.
Okay.
Yeah, so this minus 2, so the minus 2 that I'm timesing by x came from us finding the pattern of subtracting 2 each time. Okay. Right, just quickly for those of you asking, how did we get 7? Remember, we had the minus 2 times x, but minus 2 times that first input of 1 is negative 2. I don't want an output of negative 2. I want an output of negative 5. So this plus 7 came from me saying, what do I need to add to negative 2 to get 5? And that would be 7. So I asked myself, what do I still need to add or subtract to get the output that I wanted? So that's where the 7 came from. And guys, if you read the steps here, that's exactly what number 3 says. It says, how can I get from the product to the output that I want? So how did I get from negative 2 to 5? I add 7. So how do we know the number of the product at number 3? Okay, so the number of the product, or the product that I specifically want to work with, or whatever the case may be, is me, your English, let me try that again, is me finding the product of the inputs that I'm working with. So basically, I took an input of 1 and I times it by the negative 2, because that's what our rule said. Negative 2 times 1 gave me negative 2. And then I needed to ask, how do I get from negative 2 to 5? Well, I add 7. So that product comes from my inputs. Okay. It's Malay.
Oh, ma'am, can I ask?
Yes.
So, ma'am, the 7, do you also include it on the table? Do we write it down on the table?
So it's not going to come into the table. It's part of our rule, though. So that's why over here in our algebraic rule, we have the 7, but it doesn't come into our table. The only part that comes into our table is us saying from 1 to the next, we're subtracting 2.
Oh, okay. Thank you.
Okay, good. Sorry, guys. Wandisile?
Hey, ma'am. How did we get the 7, ma'am?
Okay, I've just explained it, so I would go and rewatch the video, okay?
Yes, ma'am. Thank you.
Tandawake?
Oh, ma'am, I don't understand, ma'am, also understand that general rule. How did we get to y equals to negative 2x plus 7?
Okay, so Wandisile, I would listen again. Just apparently I just need to figure this out. Okay, so how I got to my rule, guys, and this is also answering the question of where did we get negative 2? We got negative 2 because that is what I was doing each time. I was subtracting 2, all right? So that negative 2, remember, first step says multiply x by whatever we are adding or subtracting. So we would take the negative 2 and we would multiply it by x. So that is where, Tandawake, we get the first term minus 2x. But from there, that's definitely not giving me my output of 5. What I want to do is I need to say, okay, 1, remember, that's my x value, times negative 2 gives me negative 2. I don't want negative 2. I want 5. So negative 2 plus 7 will give me 5. And so that's where I'm getting the plus 7 part, or the second term of my rule, because that is essentially getting me to the output that I want. So you can take any of your inputs now while I'm here. Let's just, whoopsie daisies. Right, so if I take now my input of, let's choose a completely different color that's a bit more out there. So if you go and have a look at this table here, let me just take all of this off. If I go now have a look at that column, the input of x, which is 2, and the output 3. I'm just going to do it again. It's right here, but let's do it again. If I take x equals 2, I want to check that I get y equals 3. So use my rule. Y is equal to negative 2 times x, so times positive 2 plus 7. Negative 2 times 2 is negative 4. Don't know what's happening here. And then I say negative 4 plus 7. Negative 4 plus 7 is 3. It is the same y value, and so my rule is correct. Right, I'm not repeating again. Anyone who needs a repetition, you need to go and watch the video, please. Right, I'm hoping we've all taken our screenshots. I hope you've all had a stretch. Right. Okay, I'm going to have to shift things around a bit, but don't stress. We're just going to roll with it. Yes, you can find the videos on YouTube, but you can also find them on Watobe's website, watobe.com. Okay. So guys, let's have a look at this table, right? Whoopsie daisies. So many things happening. So the table, as you can see, and if you can't see it, let me just make it quite clear that we are getting here. The table, so the 7, 10, 13, 16 is the pattern I've given you here. So all I've done is just written the pattern from the table into a sequence. Sometimes that's quite helpful, isn't always. Let's see what happens. So guys, remember, we're working with an X and we're working with a Y. So X is the position of the term, as I've already explained to you. And if you weren't listening, I explained it to you right here in the first example. X is your position, first, second, third, and Y is the value of the term in your sequence. Okay, so all of these values here in my number pattern are Y values. They're output values. Okay, so the first thing we want to do is we want to figure out what our pattern is. So as Kaylee said there, we're adding 3. Let's see if we agree. 7 to 10, yes, I add 3. 10 to 13, yes, I add 3. 13 to 16, yes, I add 3. Good. Okay, so we know what our pattern is. That means if we now want to get, excuse me, our first term, we take 16, we add 3, and exactly as someone put there on the group, Nelson put there on our group for us, we get 19. If we add another 3 to get our 6th term, we get 22. If we add another 3, we get, whoopsie daisies, 25. So we can keep adding 3 to get our pattern, but remember, we don't want to have to sit here and add 3 up until the 50th pattern or the 110th pattern or whatever. That is going to take us way too long. We don't want to do that. So what we want to do is we want to find a rule. Right, so just ignore this n here. I'm going to change this to an x because we're not going to get to that today, but it's fine. So if we have a look at this x, all right, x basically means a general rule. And what a general rule does, as I've already said, is it allows us to find any number in our pattern, any term in our pattern we can find with our rule. So if we go back to the steps, I'm not going to keep going back and forth, but if you have a look at the steps that we did here, those 4 steps that we spoke about, we're going to follow that to find out what our rule is going to be. So the first step was multiply x by whatever we're adding or subtracting. Okay, so that's our first step. I'll number it for us. Step number 1, multiply x by whatever we're adding or subtracting. So we're going to say positive 3, because that's what I'm adding or subtracting, times x. That gives me 3x. Okay, step number 2, we go back, check if it gives us the output that we want, right? So if, maybe we should write this down as well. So step number 2, if my input, so if x is equal to 1, I want an output of 7. Now, currently, all I have is 3 times x. So let's see what happens. If I've got x equals 1 and I say 3 times positive 1, I'm getting 3. But that's not what I want. Remember, we just wrote down that we want an output of 7. So the question I need to ask myself is, whoops, let's just get rid of that, is how do I get from 3 to 7? Because remember, 7 is what I want. Right, good, guys. Well done there on the chat. I need to add 4. So if I now take this 3 and I add 4 to it, I get my output of 7, because we know that 3 plus 4 is 7. Excuse me. The third step is I want to double check, well, third step is figure out what I'm adding or subtracting, which we've done. So this would be step number 3. And step number 4 is to double check that what I've got going on is correct. Now let's just summarize what we've got going on. We have said that we need to times x by 3, so 3x, and then we discovered that I'd have to add that 4 to get to the 7, so plus 4. So what we're saying here is that our rule should be y is equal to 3x plus 4. That is hopefully going to be my rule for the pattern that I'm working with. Oh, this has turned into a chaotic highlighting endeavor. Right. Now we're going to double check. That is our 4th step. We always check. So if x is equal to, now let's go to our table. If x is equal to 2, we want an output of 10. So we want y to equal 10. Let's double check. Y is equal to 3x plus 4. We're going to put that x equals 2 into our equation. So y is equal to 3 times 2 plus 4. 3 times 2 is 6. And 6 plus 4 is 10. Perfect. Look at that. We wanted, let's just go back. We want a y value of 10. We have just worked out that we get a y value of 10 with our rule. Awesome. So that probably means that this rule is correct. If you want to triple check yourself, that's obviously absolutely fine. If we want to triple check, we'll go here, we'll take our input of 3, and we'll do exactly the same thing. So if x equals 3, we want y to be 13. So let's just triple check just to make sure. Y is equal to, y is equal to 3 times 3 plus 4. 3 times 3 is 9. 9 plus 4 is 13. And look at that. What we wanted was y equals 13. That's what we said we wanted. And what we got was y equals 13. So we have confirmed for ourselves that this rule is correct. Okay, so I'm just going to leave that there for you to take a screenshot. There is no quiz today. Quiz day is Wednesdays, so that is when we do quizzes. X, Zindani, X is, as I've explained, X is the position of the term. So X is this first row in your table. And we substitute values for X as we go along to check our calculation. So that's why I've got X equals 2 and X equals 3. I'm taking that from my table and substituting in order to check that my rule is correct. All right, make sure you've got screenshots.